Whenever a reception departure movement in the yard is to be done, the signal button and route button concerned shall be pressed and released simultaneously, thereby all the points in the route overlap and isolation shall be set and locked in the desired position automatically. Energization of NWKR or RWKR indicates that the points are set and locked. After setting of the route, it is checked by route checking relay UCR, and if it is found correct, it picks up. The following features are incorporated in the designing of UCR. Each signal will have its own UCR. UCR will be named after the signal number. This relay is normally de-energized relay. It energizes whenever the signal button and route button are pressed and released simultaneously, provided all other required conditions are satisfied. In UCR circuit, all points in route, overlap and isolation that is set and locked are proved. To achieve locking of conflicting signals, front contact of ASRs or back contacts of UCRs of conflicting signals are proved in UCR circuit. TLSRs or TRSRs and OVSRs are also proved. The NNR back contact and NRR front contacts concerned to signal movement are also proved in UCR. Crank handle CHIN is also proved in UCR, so that once checking completed and route locked, further route should not be altered mechanically, manually by cranking. UCR front contact is proved in HR circuit. UCR back contact is proved in ASR circuit. This is utilized to drop ASR as soon UCR picks up, that is, to lock the route as soon as it is checked. The double cutting is provided by NRR's front contacts and cross protection is provided by NRR's back contacts. Siding point KLPR and NWKR in case of facing front contacts are proved in UCR. In the home signal UCR circuit diagram, crank handles are in is proved by CH1 LR pickup, CH2 LR pickup. Conflicting signals are at on is proved by OV26 SPR pickup, shunt 21 ASPR2 pickup, shunt 23 ASPR2 pickup, S26 UCR drop, S30A ASPR2 pickup, S30 ASPR2 pickup, S1A ASPR2 pickup. A. Points in the route overlap for down main line is proved by 11 NWKPR2 pickup, 13 NWKPR1 pickup, 18 NWKPR1 pickup, 20 NWKPR1 pickup. B. Points in the route overlap for common loop overlap set to sand hump is proved by 11 NWKPR2 pickup, 13 RWKP1 pickup, and 18 NWKPR1 pickup. C. Points in the route overlap for common loop overlap set to main line is proved by 11 NWKPR2 pickup, 13 RWKPR1 pickup, 18 RWKPR1 pickup, 20 NWKPR1 pickup. A. NNR drop NRR pickup for down main line is proved by S1 DMT NNR drop, S1 DMT NNPR drop, S1 DMT NRR pickup. B. NNR drop NRR pickup for common loop overlap is set to sand hump is proved by S1 CLT NNR drop, S1 CLT NNPR drop, S1 CLT NRR pickup. C. NNR drop NRR pickup for common loop overlap set to main line is proved by S1 CL80 NNR drop, S1 CL80 NNPR drop, and S1 CL80 NRR pickup. Double cutting is provided by NRR pickup. Cross protection is provided by S1 DMT NRPR drop, S1 CLT NRPR drop, S1 CL80 NRPR drop. Apart from the features mentioned in the topic, designing UCR circuit, additional features that needs to be proved in calling on UCR are: when a calling on signal is provided below a running or main signal, then main signal UCR back contact is proved instead of ASR front contact, because calling on signal is required to be taken off when the main signal has failed to take off. The overlap points position NWKRs or RWKRs is not proved in calling on UCR. On completion of automatic operation of points, that is points in the root and isolation only, then the calling on signal S1A UCR picks up, proving the following conditions. Crank handles are in is proved by CH1 LR pickup, CH2 LR pickup. Conflicting signals are at on are proved by shunt 21 ASPR2 pickup, shunt 23 ASPR2 pickup, S26 UCR drop, S30A ASPR2 pickup and S30 ASPR2 pickup only when point number 20 is reverse. 26 OVSPR pickup, S1 UCR drop, S3 UCR drop, S4 UCR drop for down main line, S4 UCR drop, S1 UCR drop for common loop. Points in the root are set to normal, proved by 11 NWKPR2 pickup, 13 NWKPR1 pickup, down main line, 11 NWKPR2 pickup, 13 RWKPR1 pickup, common loop. Double cutting is provided by NRR pickup, S1A DMT NRR pickup, down main line, S1A CLT NRR pickup, common loop. Root normal relay NNR concerned is in drop condition is proved by S1A DMT NNR drop, S1A DMT NNPR drop, down main line, S1A CLT NNR drop, S1A CLT NNPR drop, common loop. Cross protection is provided by NRR S1A DMT NRPR drop, S1A CLT NRPR drop. Now let us learn about the shunt signal UCR circuit. Let us consider the shunt 21 shunt signal. Crank handles are in is proved by CH1 LR pickup, CH2 LR pickup. Conflicting signals are at on are proved by 3/4 ASPR1 pickup, S1 ASPR1 pickup, S1A ASPR1 pickup, S26 27 28 ASPR1 pickup when 11 is reverse, S6 RR drop, 26 OVSPR pickup, shunt 10 ASPR1 pickup when 11R and 13N for down main line, shunt 10 ASPR1 when 11R and 13R for common loop line. Points in the root are set and locked is proved by 20 NWKPR2 pickup, 18 NWKPR1 pickup for down main line, 20 NWKPR2 pickup, 18 RWKPR1 pickup for common loop line. Root reverse relay NRR concerned is picked up and is proved by double cutting shunt 21 DMT NRR pickup, shunt 21 DMT NRPR for down main line, shunt 21 CLT NRR, shunt 21 CLT NRPR for common loop line. Root normal relay NNR concerned is in dropped condition is proved by shunt 21 DMT NNPR drop and shunt 21 CLT NNR drop. Cross protection is proved by shunt 21 DMT NRPR drop and shunt 21 CLT NRPR drop. Let us now understand about a starter UCR circuit. Let's consider the up main line starter S3. Crank handles are in is proved by CH1 LR pickup, CH2 LR pickup. Conflicting signals are at on are proved by shunt 21 ASPR1 pickup, shunt 23 ASPR2 pickup, S1A ASPR1 pickup when 13N shunt 10 ASPR1 pickup when 11R and 13N S4 UCR drop. Points in the route are set and locked is proved by 18 NWKPR1 pickup, 20 NWKPR2 pickup. Double cutting is provided by NRR pickup, S3 NRR pickup, S3 NRPR pickup. Route normal relay NNR concerned is in dropped condition is proved by S3 NNR drop. Cross protection is provided by S3 NRPR drop. Designing ASR circuit. The approach lock stick relay ALSR or ASR is normally an energized relay with a stick path provided. Route checking relay checks the route whenever a route is set. If the set route is found correct, UCR energizes, which causes the ASR to drop. Dropping of ASR causes OV SRs and TLSRs or TRSRs to drop. Thereby, all the points in route overlap and isolation are locked as the front contacts of ASR, OVSR and TLSR or TRSRs are proved in NWLR or RWLR or WLR circuit. The drop contacts of ASR, OVSR, TLSR or TRSR are proved in HR circuit to prove the route is locked before signal is taken off. As you see in the block diagram of ASR, the ASR circuit consists of following three circuits: indication locking, back or route locking, approach locking. In addition to above three lockings, UCR back contact is proved and all the route reverse relay back contacts. NRRs down concerned to that signal are also proved. Sequential route release circuit and emergency cancellation circuits are taken off from this circuit as shown in the diagram. Let us consider S1 ASR for the study of different lockings. For that, let us take off S1. Now let us first learn about indication locking. Indication locking. Before releasing the route, that is ASR picking up, signal assumed on aspect is proved in indication locking. For color light signals, RECR front contact is not used to prove the integrity of on aspect of the signal lamps, as red lamp failure may cause the route locked condition, thereby causing delay to traffic. To avoid the above undue delay, instead of proving an energized contact of RECR, all the de-energized contacts of signal controlling relays and their lamp checking relays ECRS down are proved. Now let us look at back or route locking. Back or route locking. After the train passes the signal, it shall not be possible for station master to alter the route unless the train clears the entire route. To achieve this, route or back locking is provided. All the track circuits just after the signal to last point zone track in route will be proved in back or route locking. Where sectional route release is used, the first route section is directly controlled by the ASR concerned. The subsequent route sections are controlled by the TLSR or TRSRs. Therefore, only first route section tracks are proved in back locking of ASR. Now let us look at approach locking. Approach locking is provided in ASR circuit to prevent releasing of route in the face of an approaching train and to prevent the route being altered. Approach locking is provided in three parallel paths, that is, sequential route release path, cancellation path, that is full route emergency cancellation, approach track path. These three paths are explained under the topic Different Ways to Energize ASR. Different ways to energize ASR. ASR can be energized by the following different ways: sequential route release, full route emergency cancellation, approach track not occupied, calling on cancellation. Sequential route release. When a signal is taken off, the train passes the signal and travels over the set route, thereby picking up the ASR only when the following conditions are met. The sequential route release relays UYR 1, 2, 3 have picked up through ASR back contact, indicating the sequential directional movement and arrival of train. The track circuits in the entire route up to berthing track have picked up behind the train. The controlling switch, if any, has been normalized, or route reverse relay, that is NRR's up concerned, is dropped. The signal is put back to on and the controlling relays and indication relays have dropped. Once ASR picks up on arrival of a train, the sequential route release relays UYR's drop to be activated for another signaled movement and proved in HR circuit. Once picked up, ASR gets its stick feed bypassing the switch normal contact or NRR's back contact, back locking track circuits and approach locking circuits, etc. This is to prevent dropping of ASR due to backlock track circuit dropping during other signal movement, or track circuit failure or switch contact failure when signal is not given. When S26 is taken off and the train is moving over 1380, 13BT and 1180, S1 ASR does not drop. Once ASR picks up, the locking on the points is released. Now let us look at another way to energize ASR. Full route emergency cancellation. Cancellation path. Sometimes it becomes necessary to cancel the route given for a train. The reasons can be the signal failed to take off and needs to be tried again. The train may be required to be admitted to another route, or other train may need to be dealt first. In any case, it must be first ensured that the signals are put back to on if already taken off, and the train has not passed the signal and stopped in rear of the signal. In such case, emergency cancellation is adopted. Now let us take off S1 for down main line. By that time, the controller has instructed the station master on duty to receive the train on loop line for giving precedence to the express train following this train. The station master presses the signal button and EGGN button to throw the signal to danger. The station master then presses and releases the S1 button and down cancel button. After 120 seconds, ASR picks up and route gets release. Since dead approach locking is adopted for S1 signal, let us study approach locking through S4 signal, that is S3 or 4 ASR. Now let us look at energization of ASR when approach track is not occupied. Approach track not occupied. Once ASR drops on clearance of signal, it can also be energized on cancellation without any time delay. But this is possible only when the train is not in approach but sufficiently far away and has not occupied the approach track. Then the station master cancels the signal and the route. The ASR picks up immediately without any time delay. To ensure that the train is not in approach of the signal and is far away, sufficient length of track circuit, which is normally the length equivalent to braking distance, is provided in rear of a signal, and the track circuit clear is proved in cancellation path without time delay. Approach track for different signals are: for home signal, the track from home to distant including calling on track. For mainline starter, mainline berthing track including all other tracks up to home. For loop line starters, loop line berthing track only. For shunt signal, only one track in rear of the signal. If the approach track is clear, then the ASR picks up immediately. If they are already occupied at the time of cancellation, then timer circuit will be activated and the ASR picks up with a time delay of 120 seconds. Every cancellation is registered in a counter. Now let us look at calling on cancellation, which energizes main signal ASR. Calling on cancellation. Let us think S1 signal is taken off to down main line, but on arrival of the train ASR did not pick up as backlock track 1180 failed. Whenever the route is locked due to backlocking track failures, then calling on signal is initiated and calling on ASR drops. Immediately calling on cancellation is applied. COCAR up. After 240 seconds of time delay, calling on NJPR picks up, which picks up the main signal ASR. Through main signal ASR, pickup contact calling on ASR also picks. In this way, the route is released without the S&T person's intervention. Let us now learn about the ASRs for various signals like home signal, mainline starter, loop line starter, shunt signal, calling on signal. Home signal. Let us study S1 ASR circuit. S1 ASR circuit has the following parts: indication locking, normalization of signal route, backlocking, approach locking, sequential route release path, cancellation path. Dead approach locking is provided for S1, calling on cancellation path, stick path, cancellation circuit takes off point, sequential route release circuit take off point, mainline starter. Let us study mainline starter. Mainline starter circuit has the following parts: indication locking, normalization of signal route, backlocking, approach locking, sequential route release path, cancellation path, approach track path, stick path, cancellation circuit takes off point, sequential route release circuit take off point. Loop line starter. Let us study loop line starter. Loop line starter circuit has the following parts: indication locking, normalization of signal route, backlocking, approach locking, sequential route release path, cancellation path, approach track path, stick path, cancellation circuit takes off point, sequential route release circuit take off point. Shunt signal. Let us study shunt signal. Shunt signal circuit has the following parts: indication locking, normalization of signal route, backlocking, approach locking, sequential route release path, cancellation path, approach track path, stick path, cancellation circuit takes off point, sequential route release circuit take off point. Now let us look at calling on ASR, which energizes ASR. Calling on ASR. When the calling on signal S1A is taken off, all the points required are set automatically. Then calling on signal S1A UCR picks up, thereby the calling on S1A ASR drops and all the points in the root and isolation are locked by not allowing NWLRs or RWLRs to pick up. After 120 seconds, S1A signal clears. The moment a train clears the calling on-track circuit, 1A TPR picks up and results in S1ACO HR down, calling on HR, S1ARR down, and S1ACO AR down. Dropping of S1ACO HR causes the calling on ECR S1ACO HECR down, thereby indication locking for S1A ASR is satisfied. Dropping of S1A RR causes S1A DMT NRR down, which causes S1A UCR down, thereby normalization of signal route is achieved through S1A DMT NRR down, S1A RR down, and other NRRs are readily available in dropped condition. On complete arrival of the train, the calling on S1A ASR does not pick up automatically like other signal ASRs. To pick up calling on S1A ASR, calling on cancellation has to be initiated by pressing and releasing signal button S1 and calling on cancellation button simultaneously, thereby calling on cancellation relay S1A COCAR picks up and sticks through its own front contact. The moment S1A COCAR picks up, 24-volt supply is extended to the timer 120 seconds, and calling on cancel indication CO cancel JKE through CONJPR down is lit on the panel. After 120 seconds, CONJPR1 picks up and 24-volt supply is extended to timer 2 120 seconds. After another 120 seconds, CONJPR2 picks up and counter is incremented by 1 count and CO cancel JKE is extinguished. The moment CONJPR2 picks up, it picks up S1 ASR. If it is in dropped condition, then S1A ASR is picked up and sticks through its own front contact. Purpose of overlap stick relay. Whenever a home signal is taken off, the ASR concerned drops. Thereby, the points in the route, in overlap and in isolation are locked. Points in the route are locked till the train clears them and the backlock tracks have picked up and the ASR picks up. But once home signal's ASR picks up, the locking effect on overlap points is released, thereby making them free, which is undesirable. How do we secure overlap and also make it flexible for train operations? Two scenarios will explain requirements of overlap locking clearly. If starter is given, then overlap points of home signal are held further by its ASR as they are in the route. Even if starter is not given, the overlap points should continue in locked position for a specified time, 120 seconds, to ensure that the train has stopped in rear of starter, after which only the points shall be free. For example, if home signal S1 ASR picks up after the train has cleared the backlock tracks and is still running on berthing track, overlap points beyond starter will become free if they are locked only by S1 ASR, which is undesirable. Thus, overlap shall be secured by another relay OVSR, which provides for safety as well as flexibility in operations. OVSR is normally energized and drops whenever the reception signal is taken off, leading towards that overlap. OVSR relay is designated with starter number beyond which the overlap is reckoned. Now let us understand the run-through condition in OVSR. Run-through condition. When home signal number 1 to down main line, the main line starter S3 and advanced starter S6 are taken off for run-through. Then 1 ASR drops, which in turn drops 3 OVSR, which prevents NWLR, RWLR of points 18 and 20 to pick up, thereby locking them. As starter number 3 is taken off, 3/4 ASR also drops, which further locks point 18 and 20 as they are in the route. These points were locked earlier by 3 OVSR also. On clearing the backlock tracks of S1 signal by the train, 1 ASR picks up. But 3 OVSR does not energize since DMT is occupied by the train. Since the run-through signals are cleared, train passes the starter number 3 and clears the DMT. Then 3 OVSR picks up immediately without any time delay. But locking on point number 18 and 20 continues as 3/4 ASR is in dropped condition. Starter not taken off. Now let us study about the starter not taken off condition in OVSR. Starter not taken off for a stopping train. Let us keep starter number 3 at on and take off home signal number 1 to down main line to receive train on down main line. 1 ASR, 3 OVSR are dropped and lock the points in the route and overlap respectively. When the train clears the backlock tracks and occupies the berthing line DMT, 1 ASR picks up. But 3 OVSR remains in dropped condition only as DMTPR is in dropped condition. The moment 1 ASR picks up through the pickup contact of 1 ASR and the back contact of 3 OVSR and front contact of 3/4 ASR, 3 OVJSLR picks up and the supply is extended to the timer 3/4 OV timer. OV cancellation indication 3 OVJKE lights on the panel. After 120 seconds, the S3/4 OV NJPR picks up with 3 OVJSLR and S3/4 OV NJPR up. 3 OVSR picks up and sticks to its own front contact. The OV cancellation indication 3 OVJKE is extinguished. The purpose of stick path to OVSR is to prevent dropping of OVSR during track circuit failure. Once OVSR picks up, OVJSLR drops and cuts off supply to timer, thereby NJPR drops. The back or route locking provided on signal is sometimes cumbersome and time-consuming since all the points in the entire route are locked till the train clears the full route it has entered, and the points cleared by the train cannot be utilized for other movements. In big or major yard with busy traffic, the complete route locking hampers the efficiency and causes unnecessary detention. Hence, another type of route locking is adopted. In this system, the entire route is divided into small sub-route sections according to the point zones. When the signals are given for a particular route, all the sub-route sections in the route are locked. Thereby, the entire route is locked. But the train, on clearing each subsection of the route entered, clears the locking affecting that sub-route section. Thereby, those points cleared by the train can be utilized for other movements. Therefore, the flexibility of the yard is improved by using sectional route release. The first route section is directly controlled by the ASR concerned. The subsequent route sections are controlled by the track left stick relays, TLSRs, or the track right stick relays, TRSRs. Depending upon the direction of signal movement, TLSR or TRSRs are designed. For leftward movement, that is from right to left, TLSR, and for rightward movement, that is from left to right, TRSR is used. The TLSR or the TRSRs do the same job as that of ASR, and the TLSR or TRSR pickup contact is used in WLR circuit. When the signal is given, ASR drops, which in turn drops the required TLSR or TRSRs to achieve complete route locking. ASR picks up on clearing the first route section, and the points in the first route section becomes free. Subsequent route sections are still locked. As the train clears section by section, the locking affecting that section is released. Thereby, the points are released accordingly and they can be utilized for other movements. With TLSRs or TRSRs, the ASR circuit shall be modified accordingly with back lock track circuits up to the first route section or up to the first point. In this yard, sectional route release is provided when signal number 30 is taken off to common loop, thereby S30 ASR and 18A or B TRSR are dropped. Dropping of S30 ASR locks the route up to 20 ATPR. Dropping of 18A or B TRSR locks the route from 18BT to 18AT, that is point number 18, is kept under locking. Subroutes released by train passage. When train passes the signal, S30 travels over the set route by dropping and picking up of tracks sequentially. S30 ASR picks up as soon as the train clears 20 ATPR. S30 UYR1 picks up through S30A ASPR2 pickup, S30 ASPR2 drop, 20 RWSR2 pickup, 20 ATPPR pickup, 20 BTPR drop, 30 TPR drop, S30 TSR drop, and sticks through its own front contact. S30 UYR2 picks up through S30A ASPR2 pickup, S30 ASPR2 drop, 20 RWSR2 pickup, 20 ATPR drop, 18 BTPR drop, 20 BTPPR pickup, UYR1 pickup, and sticks through its own front contact. As soon as S30 ASR picks up, point number 20 becomes free. As soon as train occupies 18BT, 18A or BUYR1 picks up through 18A or BTRSPR2 drop, 20 ATPR drop, 18 BTPR drop, 18 ATPR pickup, 18A or BTSR drop, and sticks through its own front contact. When the train touches the berthing track, 18A or B UYR2 picks up through 18A or B TRSPR2 drop, 18 BTPR pickup, 18 ATPR drop, and CLTPR drop, and sticks through its own front contact. As soon as the train clears 18AT track and occupies the berthing track, 18A or B TRSR picks and releases the route, that is point 18, also becomes free and all the white stripe lights on the route section get extinguished. Emergency route cancellation (EUUYN). If signal S30 is taken off to common loop with overlap set to sand hump and later it becomes necessary to cancel the set route as per the controller's instructions to receive the train on main line. Then station master puts back S30 to danger by pressing and releasing S30 signal button and EGGN button. He also initiates route cancellation by pressing and releasing S30 signal button and up cancel button simultaneously. Assuming that no approach track is provided between S30 and distance signal, 120 seconds delay is to be provided before route is released. Above operation leads to S30 JSLR picking up and initiates up timer via S30 JSLR pickup. After 120 seconds, up NJPR picks up resulting in S30 ASR picking up via S30 JSLR pickup and up NJPR pickup, then point 20 becomes free. As soon as S30 ASPR1 picks up, 18A or B TRSR also picks up via S30 ASPR1 pickup, 18 BTPPR pickup, 18 ATPPR pickup, 18A or BTSR pickup, thereby 18A or B also becomes free, hence entire route is released after 120 seconds. Please note that if 1 kilometer of approach track is provided between home and distance signals and is not occupied by incoming train, this delay of 120 seconds is not required and route release is immediate. Emergency subroute cancellation during circuit failure. If signal S30 is taken off for common loop with overlap set to sand hump with passage of train occupying 18 BT and clearing 2080, S30 ASR picks up and route section up to 2080 is cleared. But 18A or BTRSR holds the route up to common loop berthing track. Let us assume that train has cleared the 1880 and occupied common loop berthing track, but due to a failure in the 18A or BUYR circuit, 18A or BTRSR has not picked up, that is, route is not released. Then station master presses and releases up route cancel button and 18-point button. Now 18A or B JSLR picks up and sticks through its own front contact and initiates up timer. After 120 seconds time delay, up NJPR picks up resulting in 18A or BTRSR picking up, which sticks through its own front contact and subroute gets released. Emergency subroute cancellation without cooperation. If signal S30 is taken off for common loop with overlap set to sand hump with passage of train occupying 18 BT and clearing 20 AT, S30 ASR picks up and route section up to 20 AT is cleared. Let us assume that train has cleared the 18 AT and occupied common loop berthing track, but 18 BT track fails to pick up after passage of train. 18A or B TRSR continues in drop condition, thus resulting in route not getting released. Here we may utilize same procedure of route release provided for calling on signal which does not depend on track circuits. Here station master presses S30 signal button and COGGN button. Then keeping S30 signal button in pressed condition, presses CLT route buttons and releases both the buttons for initiation of calling on signal S30A to common loop. Soon station master initiates calling on cancellation. After 240 seconds, CONJPR2 picks up, thereby 18A or B TRSR picks and route section released. Emergency subroute cancellation EUYN with cooperation. If signal S30 is taken off for common loop with overlap set to sand hump with passage of train, occupying 18 BT and clearing 20 AT, S30 ASR picks up and route section up to 20 AT is cleared. Let us assume that train has cleared the 18 AT and occupied common loop berthing track, but 18 BT track fails to pick up after passage of train. 18A or B TRSR continues in drop condition, thus resulting in route not getting released. To release the route, two persons, that is S and T, and operating have to cooperate to ensure safety as track circuit has failed. First, station master ensures that signal is at on and contacts the junior engineer or section engineer to insert the subroute cancellation key EUYN on the panel and breaks EUYN seal and turns disk, obstructing the button for pressing. Then station master presses and releases 18-point button and EUYN button simultaneously, thereby 18A or B TRSR gets energized via S30 ASPR1 pickup, 18 WNR pickup, EUYNR pickup, and 18A or B subroute is released without any time delay. Track stick relay TSR is normally an energized relay. After a signal is taken off for a train and the train passes the signal, the TSR drops and puts back the signal to on immediately. Let us take off signal number S1. The TSR is controlled by first track circuit immediately in advance of the signal and normalization of signal controls. NNRs pickup and ASR pickup. TSR does not pick up unless signal clearance controls are normalized by the operator or by the completion of the movement of the train. Thereby, TSR ensures that the signal does not re-clear automatically, though all other conditions are favorable. In this way, TSR circuit ensures one signal, one movement feature. TSR front contact is proved in HR circuit and is made to slow to release to avoid HR dropping if the TSR controlling track bobs. In case TPR is QSPA1, slow to release arrangement for TSR is not required. TSR can be provided individually to each signal, and also it can be combined for 2 or more signals. In this yard, individual TSR is provided for home signal S1. The first track immediately in advance of signal number S1, 1 TPR, is used as a controlling track for 1 TSR. To pick up S1 TSR, all the front contacts of NNRs concerned to S1 and 1 TPR front contact are used. The stick path is provided by its own front contact. A combined TSR can be provided for signals which are conflicting in nature and have some common controlling track circuits. In this yard, S3, S4, shunt 21 are conflicting signals and have common controlling track circuits. A combined TSR is provided. 18B TPR, 18A TPR, 20A TPR are used as controlling tracks for S3 shunt 21 TSR. To pick up S3 SH21 TSR, the front contacts of NNRs concerned to S3, S4, shunt 21 and front contacts of 18B TPR, 18A TPR and 20A TPR are used. The stick path is provided by its own front contact. For receiving a train, to design signal controlling circuit HR, the following conditions are to be proved. Let us take off home signal S1 to down main line to study those conditions. The station master's key is inserted and turned to normal to ensure authorized operation, SMR or SMCR pickup. Crank handles are in, that is proved by CHLR's pickup and CHFR's drop. Sequential root release relays UYR1, UYR2, UYR3 are de-energized after the last train movement. No signal cancellation is initiated, that is JSLR drop. Calling on cancellation is not initiated, which is proved in case calling on signal is provided below the main signal. Conflicting signals are at on is proved by proving the front contact of ASRs or back contacts of UCRs. All points in the route overlap and isolation are set and locked as per the signal concerned. For home signal, points in the route isolation and overlap. For starter signal, points in the route and isolation. For shunt signal, points in the route isolation is not compulsory. For calling on signal, points in the route and isolation. All backlock and controlling tracks are clear, that is, TPRs concerned are up as follows. For home signal, track circuits in the route, berthing line and overlap. For starter signal, track circuits up to next stop signal in advance. For shunt signal, track circuit in the route. For calling on signal, no tracks are proved. Calling on track should be occupied for initiation. Route checking relay UCR is up. One signal, one train movement TSR pickup. ASR, OVSR and TLSR or TRSR of the signal concerned are to be proved in dropped condition. Signal ahead is not blank, GECR pickup or RECR or HECR or DECR pickup in parallel. Route indicator lamps are not lit for main line, UHRs or UGRs and UECR drop. Route indicator lamps are lit for loop lines, UGR or UHR and UECR pickup. Cross protection is provided for the signal control relay by the front contact of ASR or back contact of UCR. These contacts are not favorable for signal clearance. Double cutting is provided by UCR pickup, ASR drop and LXPR pickup when LC gate is in the route. Sidings in the route and overlap are kept normal. Siding KLPR pickup. Interlocked LCs, if any in the route and overlap, are locked and closed against road traffic, LXPR pickup, and held locked till the passage of that train is over. Signal button is in released condition, GNR down. Signal control relays, HR, UGR, DR, are made slow to release. Let us take off signal number S1, S3 and S6 for run-through down main line. Conditions for S1DR to pick up. S1 UECPR drop, its own HR in the picked up condition. 3DR pickup, mainline starter DR is picked up. 3 DECPR pickup on negative line. Mainline starter proceed aspect is burning. Cross protection is achieved by back contact of 3 DECPR. Whenever a junction type route indicator is used on a home signal and if home is taken off to a loop line, then UGR is energized first. Then 110 volt AC supply is extended to route lamps and UECR picks up when minimum 3 route lamps are burning. Then only HR is picked up through front contacts of UGR and UECR. Calling on signals are used nowadays very widely to increase the efficiency of signaling system. Calling on signal is an emergency manager in the sense that this is used when the main signal above has failed. Calling on signal is taken off even for receiving a train on an occupied line. Therefore, it is useful to deal with traffic during track circuit failure also. With calling on signals, the detentions are minimized. To study the features of calling on signal HR, let us take off calling on signal S1A to common loop. It is desirable to provide track circuits of a sufficient length in rear of the signal and a time delay circuit to ensure that the calling on signal is taken off only after the train has been brought to a stop. To achieve this, the train has to occupy the calling on track provided at the rear of the signal and stop at the foot of the signal. Then calling on signal is initiated and cleared after 120 seconds. The calling on signal shall not be capable of being worked at the same time as the main signal above or shunt signal below it, if any. A calling on signal shall detect all points in the route which the main signal above detects, excluding those in the overlap. Route indicator above the main signal is not lit for calling on signal. It is not required to prove any track circuit in route and overlap for calling on signal clearance. However, other conditions related to interlocking shall be the same as that of main signal above it. On passage of the train, the calling on route gets released on cancellation of calling on signal after a time delay of 240 or 120 seconds. Sometimes a sequential route release may be provided for route release of calling on signal.